Grignard reagent. Preparation of carboxylic acids from Grignard reagent. Yesterday we have seen from alcohols and aldehydes, alkyl benzenes, and next from nitriles and amides we have seen. Today, the preparation of carboxylic acids from what is that? Grignard reagent. We know what is the Grignard reagent. We got this one in alcohols, RMGX. Okay, na? When halogens are reacting with metals, now we are getting that Grignard reagent. We know that already. We have discussed in alcohols. Now that is Grignard reagent with what is that? Carbon dioxide. Okay, so we are getting from carboxylic acids carbon dioxide reacting with here Grignard reagent, then they are producing carboxylic acid. Okay, on further hydrolysis. Okay, carboxylic acids are reacting with what is that Grignard reagent, and further hydrolysis we are getting carboxylic acid. So this is the preparation of carboxylic acids from what is that Grignard reagent. Okay, so Grignard reagent means generally what we should take RMGX or MgX is the Grignard reagent. We know X is equal to any halogen atom like 7th group elements, chlorine, chlorine, bromine, or iodine, like that. RMGX reacting with here, what is that? Carbon dioxide. See, and here also oxygen. So this is the carbon dioxide. Carbon dioxide reacting with RMGX. We know how the RMGX is reacting with carbon dioxide because one alkyl group is adding to the carbon and MgX is adding to the oxygen. We know that. So that means that is splitting to alkyl group is adding to positive charge. Where is the positive charge and negative charge for that MgX will be adding because this is metal is taking positive charge. So that is the reason alkyl group is adding to the carbon atom and MgX is adding to the oxygen atom. Then what we are getting here? So R carbon what added alkyl group R, and here carbon oxygen double bond will be, and next for other oxygen O this MgX will be adding MgX. Okay, so repeat it here once again. RMGX Grignard reagent. Okay, RMGX is the Grignard reagent. This is reacting with carbon dioxide. Then one oxygen getting negative charge and carbon is getting positive charge. Where is that? So the MgX will be adding to the oxygen atom, or alkyl group is adding to the carbon atom. Okay, Nana. So next on further hydrolysis, again reacting with water, H3O plus. H3O plus. What we are preparing here now? We are preparing carboxylic acids now. So then we are getting here carboxylic acids. That means one hydrogen is adding to here. So then that will be RCOOH and MgX, and OH will be is going out. Okay, MgOHX will be out. We know that when the Grignard reagent is reacting with any kind of functional group, then we are seeing that in alcohols we have seen that. So MgOHX will be releasing. So remaining alkyl group is adding to the carbon atom. So that is the reaction. So now write down here RCOOH. Here RCOOH. Here hydrogen is adding. So we are getting here RCOOH. So is enough. If you can write here MgOH. So this is the preparation of carboxylic acids from what is that? Grignard reagent. Preparation of carboxylic acid from Grignard reagent with what is that? Carbon dioxide. Once again, listen all of you. Grignard reagent is reacting with carbon dioxide, CO2. Okay, na? So alkyl group is adding to the carbon atom and MgX is adding to the another oxygen atom. Then on further hydrolysis, again that RCO will be there no for oxygen. MgX will be taking OH and releasing out, and oxygen is taking hydrogen. Then that is converting into RCOOH, Nana. RCOOH, and remaining, what is remaining here? What left here? MgX. In that, Mg will be taking, what is that? Hydroxide, MgOH gas will be releasing. So this is the preparation of carboxylic acid from, what is that? Grignard reagent. Understood, all of you? All of you understood, Nana?
Yes, sir.
Yes, write down the reaction. RMgX with CO2 and RCOOMgX. Next step, on further hydrolysis, we are getting carboxylic acid and MgOH. So that is the reaction from Grignard reagent. Write down, all of you. Lokesh, are you there, Nana? Lokesh. Okay, right. Write down the reaction, Nana. Finished, Nana? Completed,
Completed, sir.
Next, from acid chlorides and anhydrides. Preparation of carboxylic acids from acid chlorides, like acyl chlorides also we can say that acid chlorides and anhydrides. Nana?
సార్ మీ వాయిస్ బ్రేక్ అవుతుంది.
ఏంటన్నా?
మీ వాయిస్ బ్రేక్ అవుతుంది సార్.
బ్రేక్ అవుతుందా? బోర్డు క్లియర్ గా ఉందా?
క్లియర్ గానే ఉంది సార్.
ఓకే, 1 minute. Now, can you hear my voice, Nana? Nana, can you hear my voice clearly?
Yes, sir.
Yes, sir.
Next from acyl chlorides and anhydrides. Acid chlorides and anhydride. From acid chlorides and what is that? Anhydrides and preparation of carboxylic acid. So acid chlorides means what is that? RCOCl. RCOCl. This only we are saying that acyl chloride also. Acyl chloride also. We can write here two reactions. We can write here two reactions. So with acyl chloride, one is from acyl chloride with H2O on hydrolysis with water and RCOCl with water directly they are giving. What is that? Carboxylic acid, how no? H plus OH minus, right? OH is adding to CO and that is converting into RCOOH, and chlorine is going out. So here what we are getting? RCOOH plus Cl minus. So this is the reaction with water on aqueous OH like base OH minus OH with OH minus. So also they are producing what is that? Carboxylic acids here. So OH is adding to what is that? CO nana. So no here the carboxylic ion is forming first carboxylic ion. So that means RCOO minus RCOO minus plus. Okay. So what is the forming here? Carboxylate ion plus Cl. What is remaining here? Cl only, no? Cl minus, and on further hydrolysis again H3O plus. Then this is producing here RCOOH. So this is the preparation. So from RCOCl, acyl chloride, from acyl chloride with water directly that is producing carboxylic acid, and chlorine minus is releasing. Next with base aqueous base like NaOH like that, OH is reacting with COCl and that is producing here RCOO minus carboxylic ion and chlorine, and on further hydrolysis again we are doing hydrolysis, so like acids, so H3 plus, then that is producing here RCOOH carboxylic acid. So this is from acid chlorides. Okay, anhydrides next I will give you. Okay, first on the preparation of carboxylic acid from the acid chloride or the acyl chloride, this reaction. So you can write directly if you in final examination they can ask RCOCl and directly gives rise to like that. RCOCl with OH gives rise like that, they may ask for 2 marks. Okay, or RCOCl they'll ask with water or they will ask in with OH minus like that. Okay, two reactions. If you want, you can write like two reactions only. With RCOCl only we are getting these two. From water we are getting carboxylic acid, and from OH minus we are getting carboxylic ion, and further hydrolysis we are getting here carboxylic acid, Nana. So this is the preparation of carboxylic acid from acid chlorides. Correct? Write down the reaction. All of you writing, writing, Nana, reaction.
Yes, sir.
Yes, yes.
Yes, sir.
Yes, right, Nana. So preparation of carboxylic acid from acid chlorides. So we can write these two reactions with water and base.
సార్ బోర్డ్ క్లారిటీ లేదు సార్, బ్లర్ చేస్తుంది సార్, ఏం రాయడానికి అర్థం అవ్వట్లేదు.
Okay, okay, okay. ఇప్పుడు చూడండి అన్న ఒకసారి.
ఓకే సార్.
ఓకే అన్న.
థ్యాంక్ యూ
పైకి పెట్టండి సార్.
కొంచెం పైకా?
సార్.
సార్ చేయండి సార్. ఓకే సార్, థ్యాంక్ యూ సార్.
ఓకేనండి.
సార్ కంప్లీట్ సార్, రబ్ చేసండి.
ఓకేనండి. We have seen what is that acid chlorides, Nana. Now from anhydrides. Anhydrides, Nana. So here hydrolysis only we are taking. So C6, 5, POO, COCH3. So this is the N hydrate, Nana. C6H5COO, COCH3 we are taking. So on further hydrolysis, directly hydrolysis only, Nana, here. So that means reacting with water, so directly they are producing carboxylic acid. Plus. So here C6H5COOH will be formed. Okay. Two products we are getting, Nana, here C6H5 COOH, and next here CH3 COOH, Nana. CH3 COOH. That means two carboxylic acid, benzoic acid and the aliphatic acid. Once again, this is N hydrates, like how it will be CO and oxygen, and here also CO, CO, CO. So this will like this the functional group. So this bond will be taking with here. Okay. So next COOH, hydrogen is adding here, and COCH3 will be the group, but COOH is adding here. So like that, CH6H5COOH and this COOH is forming, Nana. So carboxylic acid, okay, benzoic acid. C6H5COOH means what? Benzoic acid, and this one is acetic acid. Two acids are forming, Nana, here. So this is with anhydride. So with water, directly anhydrates are reacting with water directly, and they are producing directly benzoic acid and acetic acid. Both are forming acetic acid and benzoic acid from anhydrates. Already given acid chlorides reactions with water and base, and next C6H5COO CH3. So what we are getting, benzoic acid and acetic acid. These two acids we are getting from the, what is that, anhydrates. Okay, ra? This name is anhydrate. Anhydrate with water. That means hydrolysis. We are getting C6H5COH and CH3COH. Nana. Write on the reaction. Till one more preparation is there. We have to do that also. And next physical properties.
Writing, sir. Sir, please, sir. Mali Belrosin, sir.
వచ్చిందా? అది యాప్ ప్రాబ్లం లేదు, మన దగ్గర నెట్వర్క్ కానీ రెండు ప్రాబ్లం లేదు. ఓకే, ఐ విల్ చేంజ్. Now, is it clear, ra?
నో సార్ ఇంకా చిన్న బ్లర్ ఉంది.
Karthik?
ఇప్పుడు ఓకే సార్, పర్లేదు సార్, అయినా కొంచెం
Sir,
బ్లర్
okay.
ఉంది.
పర్ఫెక్ట్లీ ఉంది సార్.
Okay, Nana. Completed, Nana?
Yes, sir.
So from anhydrates and acid chlorides we have seen the, so with hydrolysis only. So like what we have taken from acyl chloride also, water, with water directly they are producing carboxylic acids on base. On base they are producing carboxylates, then after further hydrolysis again carboxylic acids are producing, and next from anhydrates directly they are giving, what is that? If you take this one, anhydrate that is producing benzoic acid and what is that? Acetic acid. So this is the preparation of carboxylic acids from, what is that? Anhydrates and acid chlorides. Next from esters, preparation of carboxylic acids from esters. Esters, esters here also hydrolysis comes, Nana, mainly with water directly they are producing carboxylic acid. No more another reaction here. Alcohols also producing with water. So water with, what is that? Ester. Okay, na ester. RCOOR. We know the functional group with ester. Okay, we are getting carboxylic acids, Nana. Esters are reacting with water on hydrolysis. They are producing carboxylic acid as well as, what is that? Alcohol also. Okay, Nana. So write down the reaction. On the benzene ring, ester will be like this. If you take this one as R, like alkyl group or aromatic ring, okay, na? R CO OR is the, what is that? Ester. We know that, right? Like you can write here C2H5 RCH3. So this is the ester, Mana. So RCOOR, like instead of C2H5 or CH3, also any alkyl group should be present. So on hydrolysis directly, H3O plus. So what they are producing directly carboxylic acids, Nana, here. So that means RCO for this OH is adding that is benzoic acid, and next to C2H5 OH. If hydrogen is adding to this C2H5 OH, so that will be, what is that? Alcohol will be, okay. So here when the ester is reacting with water, they are producing two products. One is benzoic acid, another one is alcohol, ethyl alcohol. So write down the products here on the benzene ring. COOH nana, and next plus C2H5 OH. C2H5 OH. So this is the reaction. So once again, listen all of you. So from esters, are reacting with water. Hydrolysis. On hydrolysis, this group is completely oxidizing. That means the COOH is adding here. So next to C2H5OH. So the remaining hydrogens are adding to oxygen. So here C2H5OH is producing, and here COH, benzoic acid. So this is the preparation of what is that? Carboxylic acid, benzoic acid from the ester. Okay, na? So just directly from what is that? Water. Directly from water, they are producing carboxylic acids. Okay. If you want to write the matter, you can write down. So esters are reacting with water or hydrolysis. They are producing directly carboxylic acids. Okay, na? On base, if you take here base only OH, they are producing carboxylate ions. Then after that, further hydrolysis, they are producing here what is that? Carboxylic acids. Okay. So with carboxylic acid, with esters, they are producing carboxylic acid directly. Otherwise, if you take here base, any base, they are producing first oxalate ions, carboxylate ions. After further hydrolysis, they are giving carboxylic acid. So this is the preparation of carboxylic acids from esters. RCOOR is the functional verb. With water hydrolysis, we are getting carboxylic acid and alcohols into H5OH. Understood, Ra?
Yes, sir. Understood, sir.
Yes, sir.
Yes, write down the reaction, Nana. Preparations got over. So we have prepared from what is that? Alcohols and aldehydes. Next, alkyl benzene, nitriles, and amides, and grignard reagent. And now, what is that? Acyl chlorides and acid anhydrides. And now from esters, we have prepared like 6 preparations I gave you. Okay, anyone may ask for final examination. 6 preparations, Nana. Preparation of carboxylic acids from any esters. They may ask acid chlorides or anhydrides, or from nitriles, and what is that? Amides. Mostly they are asking from what is that? Grignard reagent and nitriles and amides. They are asking in exam, Nana. Completed, huh?
Yes, sir.
Completed.
Completed, sir.
No, next physical properties. Physical properties of carboxylic acids. Listen here. So here mainly we need to discuss about boiling point and what is the hydrogen bond is existing here. So mainly, so we have discussed the aldehydes, ketones. Okay. So here aldehydes having highest boiling point than ketone. So I told you that is regarding what is that. Because of what is that hydrogen bonding we have discussed. So because that is adding with the hydrogen, carbonyl group is adding with the hydrogen and ketones are adding with one more carbon. So that is the reason we discussed. That means aldehydes are less, aldehydes and ketones are less boiling point than what is that alcohols. Okay, alcohols higher boiling point than aldehydes and ketones. We discussed already. So and aldehydes are higher than the what is that hydrocarbons and lesser than the what is that alcohols. So lesser than the alcohols, higher than the hydrocarbons. That point we have discussed in aldehydes and ketones physical properties. But here, what is the thing? Carboxylic acid is having highest boiling point than even though alcohols. Okay, that means in this chapter, if they ask for what is the physical properties of carboxylic acids, you need to remember carboxylic acids having highest boiling point than alcohols, aldehydes, ketones, and hydrocarbons and ethers. So they'll give for 2 marks. Okay, they'll give whole. What is that? Aldehydes, ketones, carboxylic acids, and alcohols, and what is that? Hydrocarbons in that arranged order of what is that boiling point. Like that, they will ask you. Okay, so you should remember carboxylic acids having highest boiling point than what is that aldehydes, ketones, and alcohols also. Even though so. First preference you have to give the carboxylic acids. That means carboxylic acids having highest boiling point. Then after that alcohols, next aldehydes, ketones. Then after that hydrocarbons. Like that you have to give the priority and you have to give the order of the boiling point. Okay. So here why carboxylic acids having highest boiling point compared with alcohols and aldehydes and ketones due to the what is that hydrogen bonding. Here intermolecular hydrogen bonding in the molecules. Okay, so carboxylic acid with another carboxylic acid, they both are having existing with what is that intermolecular hydrogen bonding. Why intermolecular? Because not in same molecule. Okay, other molecule with other molecules they are bonding with the hydrogen bonding. So that's why here intermolecular hydrogen bonding we are saying that. So due to this reason, carboxylic acid is having highest boiling point. Okay, and up to 9 carbon atoms and like carbon chain. Okay, they are colorless. Okay, and colorless and orderless. There is no smell and there is no color for carboxylic acids up to 9 carbons and unpleasant odor. We can observe that unpleasant odor. That means like bad smell. We can see unpleasant odor means so that they are having up to 9 carbons. They are colorless and odorless. Okay, after that we can see the unpleasant odor. And one more thing here, carboxylic acids are in vapor state also. Vapor state also, they are not broken bonds. We can't observe that. So that means they are bonding with bonding in where vapor state also. Vapor state means water in like vapors are coming no with water. Okay, in vapor state also they are having bonds. They are not broken bonds. Okay, the like that. So that means carboxylic acids are existing with bonds in vapor state also. Remember that point. Okay. So in like what is the structure? No, dimer structure. Like dimer, how they are existing? I'll give the structure. So carboxylic acid take here R. Okay, RCOOR, right? Right here C carbon, and here one side if you write CO, one side we are writing here O, and here I'm writing H, OH Nana. Okay, next for this carbon, right here carbon. Okay, if you wrote here OH, no, right here what is that OH? Between that hydrogen. Okay, and next here, what will be here? Oxygen. So this is the structure, Nana. This is called as dimer. What is that? Dimer. Write down the structure, all of you. Physical properties in that write the structure dimer. That means the one carboxylic acid molecule bonding with another carboxylic acid molecule, like intermolecular hydrogen bonding. Due to the intermolecular hydrogen bonding, carboxylic acid is having highest boiling point compared with aldehydes, ketones, and alcohols. Okay, so this is the example. In this is we can observe in vapor state. Vapor state. Okay, so that's why vapor state means we know, right? So I told you just now, what is that? In vapor state also, the bonds are existing here. There is no broken bonds, but here the bonds are existing in vapor state. Remember, this is the point we have to remember in object also. In vapor state, they are existing with dimer. Dimer means two molecules are existing with intermolecular hydrogen bonding. So that is the carboxylic acid's main. Okay, dimer. Where we are observing dimer means in vapor state. In vapor state, where we can observe dimer molecules of carboxylic acids, Nana. So write this structure. Then after that, write the physical properties. I'll tell you the like three to 4 points will come that we need to write. Okay, first write this structure, all of you. Physical properties of carboxylic acids like that, and next write this structure, and next I will tell you the points. Okay, Ra?
Yes, sir.
Yes, write the structure. I will tell you the physical properties. Complete the structure, Ra. His name is dimer. Dimer.
Completed.
Completed, Nana?
Yes,
Just write
sir.
down the first point, Ra. In physical properties, first point. Aliphatic carboxylic acids aliphatic carboxylic acids, aliphatic carboxylic acids up to 9 carbon atoms, aliphatic carboxylic acids up to 9 carbons, aliphatic carboxylic acids up to 9 carbon atoms are colorless liquids. Aliphatic carboxylic acids up to 9 carbon atoms are colorless liquids. And unpleasant odor, ODOURS, odors, unpleasant odors. Again, I'm repeating the first point. Aliphatic carboxylic acids up to 9 carbon atoms are colorless liquids and unpleasant odors. ODOURS, odors, smell, like smell. Unpleasant smell and రాసుకోండి ఒకవేళ ఇబ్బంది అయితే. Aliphatic carboxylic acids up to 9 carbon atoms are colorless and unpleasant odors. Completed ra?
Yes, sir.
Yes. Next point. Carboxylic acids are higher boiling point than carboxylic acids are higher boiling point than aldehydes, ketones, and even alcohols also. Again, I'm repeating the second point. Carboxylic acids are higher boiling point than aldehydes, ketones, and even alcohols also. Okay, okay, Nana?
Yes, sir. Yes, sir. Completed, sir.
Yes, third point. Carboxylic acids are higher boiling point. Carboxylic acids are having higher boiling point. Carboxylic acids are having higher boiling point. Carboxylic acids are having higher boiling point due to the intermolecular hydrogen bonding. Carboxylic acids are having higher boiling point due to the intermolecular hydrogen bonding. Completed the next point.
Yes, sir.
Aliphatic completed the
Yes, sir.
yes. Next point. Aliphatic carboxylic acids. Aliphatic carboxylic acids having up to 4 carbon atoms, aliphatic carboxylic acids having up to 4 carbon atoms, aliphatic carboxylic acids having up to 4 carbon atoms, or aliphatic carboxylic acids having up to 4 carbon atoms are miscible with water, or miscible, M-I-S-C-I-B-L-E, miscible. Miscible means they can dissolve. We can mix with water like that. So simple. Okay, aliphatic carboxylic acids are having up to 4 carbon atoms are miscible with water. Last point, right? Writing, all of you.
Yes, sir.
Yes. Last point. Higher carboxylic acids. Higher carboxylic acids are practically insoluble in water.
Sir, higher carboxylic
Higher carboxylic acids are practically insoluble in water. Higher carboxylic acids are practically insoluble in water. The solubility decreases. The solubility decreases. About solubility, the solubility decreases with increasing number of carbon atoms. The solubility decreases with increasing number of carbon atoms. The solubility decreases with increasing number of carbon atoms. The solubility decreases with increasing number of carbon atoms. So you should remember here, if up to 4 carbons in aliphatic, they are miscible with water, like higher carboxylic acids, that means more than 4 carbon atoms, they are called as higher carbon atoms, higher carboxylic acids. If the higher carboxylic acids are not soluble in water, that point you have to remember here. Okay. And if increasing number of carbon atoms, that means that's what we are discussing. So that means higher carboxylic acids are not dissolving in water practically. That's what we are telling. If number of carbon atoms are increasing, so what is happening? So the solubility will be decreases. So that's what I told you. The solubility decreases with increasing number of carbon atoms. So that is the point here. So remember, aliphatic carboxylic acids are up to 9 carbon atoms. They are colorless and unpleasant order with unpleasant odor. Okay. Next, up to 4 carbon atoms in aliphatic, they are miscible with water. Higher carboxylic acids are not dissolving in water. Like that is affecting on solubility. That's why the solubility decreases with increasing number of carbon atoms. Okay, ra? And
Yes, sir.
main important point is what is that? boiling point. Boiling point is higher than the all functional groups like aldehydes, ketones, and even the alcohols. Carboxylic acids have highest boiling point due to the intermolecular hydrogen bonding. Okay, Nana. In this all chapters, if they give examples and if they ask you to write the order of boiling point, means remember carboxylic acids you should give first priority, then after that alcohols, next aldehydes, ketones, then after that hydrocarbons, like that. You have to arrange in object also. Okay, Ra? These are the physical properties, Nana. Tomorrow we'll discuss the chemical properties of carboxylic acids. Okay, Ra?
Okay. Okay, sir.
Okay, Nana. Bye.
Bye, sir.
Bye.